So we're now going to talk about the microservice structure and functionality for our MathServices App case study. And you'll see that this will demonstrate how we split things up into two different parts now instead of having everything put into one. It's not really that much different. Honestly, we just can factor them out a little bit different, and how we're going to apply various concurrency models here. So here's the GCD controller. Doesn't look much different from what you've seen before. It is a REST controller. It's got an auto-wired service, and it's got an entry point method called compute GCDs. As you can see, it's going to take a list of integers, and it's going to return a list of results, GCD results. And all it does is it just forwards to the underlying microservice service to do it. And we use a get mapping to do this. That's OK. Here's the route name. And then we have the request param annotation because we're passing this as a list. So if we don't put that in there, then the code won't know how to take what's coming over in a URL and decode it and turn it into a call to this list parameter. The GCDService, super simple. It uses the types that are passed to it from the GCDController. It's annotated as a service. It takes in a list of integers. And it does some interesting stuff here. And we're going to take a closer look at this when we look at the source in a second. It's going to take this list of integers, and it's going to create a stream of objects that take two adjacent integers and create basically a GCD param that are the two values we're going to do to compute the greatest common divisor. And this is a really cool example of using Java streams. We'll look at that in more detail in a second. So we're also going to make a parallel stream out of this thing, and then we're going to compute the GCD, and that's going to give us a stream of what are called GCD result objects, which are of type record. We'll talk about that. And then we'll convert that into a list, and that gets returned back as the list of GCD results. And we'll look at that in more detail when we look at the code. So let's take a look at the GCD microservice implementation. As you can see, that's the guy that does the GCD processing. We're going to use parallel streams, as we just saw, and you can get the code here at this link. We're now in the IntelliJ project for the EX3 example, and you can see that we have the GCD application. Nothing really surprising here. It's like every other Java application you've seen for Spring. Here's the GCD controller. Nothing really surprising there. Here's the GCD service. So a lot of this is pretty simple, but there's one thing I do want to focus on. So here's compute GCDs, takes the list of integers, and we're going to create something called a list spliterator, which lurks up here in the common folder. And I'll show you what that does in a second. But then I just want to point out, here's what compute GCD does. It takes a GCD param, which we'll look at in a second too, and it calls a routine in our mathutils library that computes the GCD given two integers, which come out of the param, and then we display the results, and we return a new GCD result that has the original parameter and the results. So those are the key data types we're dealing with here. And these data types are quite interesting. They are defined here in the common folder, common package. And you can see GCD param takes this interesting syntax called a record. A record, I think, might have come in Java 16. And it basically is used to define plain old data types with very simple, very, very simple methods like a constructor and getter methods. There's no setter methods because a record is immutable. Once you set the values of the record, which are its fields, you can't change them without making a new record. So it's a read-only object. And it also has some other cool properties. In particular, it doesn't have a lot of the other things you would expect to find with Java objects. So it doesn't have virtual methods, for example, so there's no virtual method table that's associated with it. There's no virtual pointer. And since it's immutable, there's no need for locks. So a bunch of things you would find with an object are missing from a record, and the intent is to make it lean and mean and lightweight. So you can see here that we have two fields, int1 and int2. And it looks kind of like a syntax for a method, but it's defining a data structure, just a very simple structure. It's somewhat like a struct in C. And then we have GCD result, and you can see GCD result is also a record, and it includes a GCD param, which has the two ints that we had, and then the results, the greatest common divisor from computing the GCD. So those are the types that we're using. We're using record types. Let's go look at the spliterator. Spliterator is pretty cool. So this is another feature that started out in Java 8 and has been used considerably by people doing customizations to the Java Streams framework. As you can see here, our list spliterator is an abstract spliterator parameterized with the GCD param. This is just a helper class that is used to provide some default behaviors so we don't have to rewrite them. We're going to have ourselves a list of integers as one of the fields and an index where we are at the moment in our traversal through this list. A spliterator can be thought of as an iterator on steroids. So if you're familiar with Java iterator, it's an instance of the iterator pattern from the Gang of Four book, and it's got some nice features that allow you to be able to iterate through every element in a collection. But it's a little bit more complicated to use, so for various reasons they made a spliterator abstraction in Java 8 to work with Java Streams. And what we do here is we take the list of integers, we stash them away in the field, and then the main method here that matters is called try advance. And try advance is going to be passed an action as basically as an out parameter, and you'll see how that works in a second. And so what we do is when we try advance is actually called with the underlying Java Streams framework to split up the data structure, in this case, this list of integers, into pieces that can be turned into a stream. And so try advance is going to see if we've exceeded the number of elements in the list of integers. If so, we're done. We return false. Otherwise, we are going to create a new GCD param that takes the next two elements in our list, gets the current element at m index and m index plus 1, makes a new GCD param for that, accepts it into the out parameter, which is this action, so it can be passed back to the streams framework. Then we increment the index by 2 to skip over the two elements that we just processed. And we tell the framework, keep going, we're not done yet, or we may not be done yet. So that spliterator is how we're going to take this list here and then split it up into GCD params and then call the compute GCD here. And one of the things I like about this is it's just so clean, separation of concerns. We deal with the input here with a spliterator. That works seamlessly with streams. We get a parallel stream pretty much for free just by passing true into the stream support stream factor method. And then everything else after that is just good old Java Streams programming. So very simple, very concise, very easy to deal with.